All right, 7.5, using proportional relationships. The first things first, I wanted to talk to you guys about what indirect measurement means. Indirect measurement is any method that uses either formulas or similar figures or proportions to help measure an object. So the example that we're going to do now is a great example of indirect measurement, and this is probably one that you've done before. Whenever dimensions are given in both feet and inches, you have to convert them to either one or the other, because otherwise it gets super messy, you guys. So if you take a look at the first example down here, this is a great example of indirect measurement and having two different dimensions. Tyler wants to find the height of this telephone pole. Okay, so he measured the pole's shadow. You get 38 feet 4 inches. And then he measures his own shadow, which is 7 feet 8 inches. And then this is as tall as Tyler is. And then he's supposed to help use that to find the height of the pole. Now, in 7A, we did a lot of this. We wrote out ratios, made proportions, and then we saw them. The only difference here is that we have different dimensions. So I prefer, instead of doing everything in decimals, I'm going to put everything into inches. Now, remember, there is 12 inches in 1 foot. Okay, so I had to take 5 times 12 and then add on my 9. So this converts it all into inches. So this becomes 69 inches. This becomes 92 inches. And this becomes 460 inches. Okay, so step number 1, convert your measurements, okay? Step number 2, you should try and see, are the triangles similar? So we want triangle similarity, and in this case, yes, by angle, okay, the 2 right angles right here, and then your 2 angles here. And now step number 3, you can go ahead and find your height. So in this case, we're going to find h. So we're going to set up our proportion. So we have 69 is to h. Oh my gosh, that was way off. And then we have 92 into 460. And we can do our wonderful cross multiplication. So we have 92h is 69,460. So go ahead and divide through, 69 times 460. I'm sorry, you guys. So you multiply those. We get 92h is 31,740. There we go. Now you divide by 92. You should get that your height is 345 inches. Okay, so the height of this telephone pole is 345 inches. Now, if I went up to someone and I told them that the height of a telephone pole is 345 inches, they would look at me like I am nuts. You don't measure telephone poles with inches. So now you have to go back. So you're going to take your 345 and do what? Divide it by 12. Okay, we end up with 28 feet, and then you have some left over, which ends up being 9 inches. Remember to convert back. So this would be like your step 4, convert back. All right, a scaled drawing, you guys, represents an object that's smaller or it could be larger than its actual size. The drawing's scale is actually the ratio of any length in the drawing to the corresponding actual length. So for example, and we use this all the time when we're traveling, on a map, sometimes the scale will be 1 centimeter to 1,500 meters, meaning that 1 centimeter measured on the map physically actually represents 1,500 meters of actual distance. Remember, you guys, a proportion can compare measurements that have different units. Don't have to worry about converting anything if it's different units, if you're comparing centimeters to meters, for instance. Now, last time we did all the same units because we were comparing inches to inches. We were trying to find the height there. But in this case, when you're trying to find comparison for scales, we can actually compare 2 different units. So this first example says, on a Wisconsin road map, Kristen measured a distance of 11 1/8 inches from Madison to Wausau. On the map, it says that the scale is 1 inch representing 13 miles. What is the actual distance between Madison and Wausau to the nearest mile? Okay, so we're going to write out some proportions here. Okay, the first ratio I see is that 1 inch represents 13 miles. So I know that 1 inch represents 13 miles. We are comparing inches to miles. Now, if I compare inches to miles, we have to compare inches to miles again. So if 1 inch is compared to 13 miles, then 11 and, oops, I don't know what happened to my pen. 11 and 1/8 inches has to be compared to what I'm looking for. Now, if this 1/8 messes with you, type it into the calculator, okay? But we know how to solve this. Use your cross products. We get x is about roughly 145 miles. Remember, we're rounding to the nearest mile. All right, the Lincoln Memorial in Washington, D.C. is about 57 meters long and 36 meters wide. Okay, so we're looking at 57 meters long and about 36 meters wide. They want you to make a scale drawing, all right, that has a scale of 1 centimeter to 15 meters. And I want to know what the actual length is going to be. Okay, so let's take a look here. I want to find the length and the width. Let's start with finding one first. First things first, I'm going to compare centimeters to meters. So I know that 1 centimeter is to 15 meters, right? If I want to find L, let's say I want to find my length, then L centimeters will be compared to 57 meters. Okay, likewise, if I want to find the width, well, I know 1 centimeter is to 15 meters. This is my scale. And then we want to find how many width centimeters is to 36 meters, the actual. Now all you have to do is do cross multiplication in both of these cases. Okay, you'll find out that 15L is 57. You'll find out that 15W is 36. So what happens when you go ahead and solve? Your length is roughly 3.8 centimeters. And your width is about 2.4 centimeters. So let's revisit what the heck we just did. Okay, they told me what the actual building looks like. It's 57 by 36. They said they want you to make a scale drawing. They gave you the scale. You have to use this scale to find these measures for your drawing. Okay, so you're going to use it. 1 centimeter represents 15 meters. Well, something centimeters represents 57 meters. This is where you get your proportion from and solve. Likewise with your width. So putting this all together, when we're talking about similarity ratios, perimeter ratios, and area ratios, if I tell you that these two triangles are similar, meaning that your sides are going to be proportional to each other, to find a similarity ratio, all you do is you compare your sides. Okay? So A to B and D to E should be the same as the others. So if you take a look, 5 to 10, this is 5 to 10, this is 4 to 8, and this is 3 to 6, all giving me a similarity ratio of 1 to 2. So the similarity ratio is 1 to 2. If you're looking at the perimeter ratio, well, all you have to do is compare the perimeters. Well, the perimeter of the small triangle, perimeter, if I add up all the sides, is 12. The larger one, if I add up all the sides, is 24. So this is 12 to 24, which is 1/2. What do you know? My similarity ratio and my perimeter ratio are exactly the same. Now let's take a look at area. The area of a triangle, you guys, area is base times height over 2, or 1/2 base times height. So if I find the area of this one, it's 1/2 times 3 times 4, which is 6. This is 1/2 times 6 times 8, which is 24. So this is 6 to 24, which is 1 to 4. All right? What you're going to notice when you go through this, your similarity ratio will be the exact same as your perimeter ratio. Now the difference is the area ratio will be whatever your similarity ratio is squared. So if I take 1/2 and I square it, 1 squared is 1, 2 squared is 4. So whatever your similarity ratio is, when you square it, or your perimeter ratio, when you square it, you will get your area ratio. All right, so given two similar figures, your similarity ratio, if it's A to B, That makes your perimeter ratio A to B. Similarity ratio is A to B. Remember, for the area, we square it. So it's A squared over B squared or A over B squared. Okay, so now this makes this whole lot easier. It says the ratio of the perimeter of ABC to DEF is, and I know it's not there, I'm going to tell you, it's 8 to 9. What is the similarity ratio? Well, we know the perimeter ratio and the similarity ratio are exactly the same. So if the perimeter ratio is 8 over 9, the similarity ratio is 8 over 9. Done and done. You don't even have to draw out the triangles. They are the same. The next one says that the ratio of the areas from these two triangles is, and I'm going to fill it in for you, don't worry, 4 to 49. What's the perimeter ratio? Well, remember, you guys, if I have the similarity or the perimeter, I would have to square it to get the area. So if I have the area, 4 over 49, to go backwards, I would have to take the square root. Well, the square root of 4 over the square root of 49 gives me a perimeter ratio of 2 to 7. Okay, it's just that easy. All you have to do is remember these rules up here. Please come with questions tomorrow, you guys. Some of this stuff can be a little bit tricky. Have a great night.